Hello class, welcome to section 14.1, focusing on basic probability theory. A lot of basic probability you probably understand the idea of saying, like when you flip a coin, chance of getting heads is 1 out of 2. So we're just going to review some of that, some of the terminology associated with it. First of all, an experiment is an occurrence whose outcome is uncertain, such as rolling a die. So an experiment describes as the book refers to it, a random phenomenon, some occurrence that we're going to be monitoring for probability. Rolling dice is one of the most common ones. Sample space are all possible outcomes for a particular experiment. So in the case of rolling a dice, or a die I should say, is 1 through 6 is our sample space. An event is a particular subset of sample space. For example, rolling a 2. So you say, well, outcome is not the same thing. Outcome is a little more specific. Event is usually defined as being a little broader. So outcome is typically one single result, whereas an event could be one or it could be multiple. So when we say the probability of an outcome, it's a single probability between 1 and 0 inclusive. That means it could be 0 or 1. When it's 0, of course it means it's definitely not happening. When it's 1, it means it's definitely happening, definite possibility, or definitely will happen, I should say. Obviously, the closer it is to 0, the less likely, and the closer it is to 1, the more likely it is. An event is the sum of probabilities of various outcomes that make up an event. So again, like I said, an event could be more than one probability, more than one particular outcome. And there are two types of probabilities that we're going to be focusing on. The first one is theoretical probability, which is what you traditionally know probability as. As I mentioned, flipping a coin, you have 1 out of 2 chance of getting heads. That's theoretical probability. So for an event E, the number of ways E our particular event can happen, and divided by the sample space. Assuming all events are equally likely to occur, and that's important. For theoretical probability, every event should be equally likely. And there we go. Empirical means experimental or observational. So an empirical or observational probability means probability based on observed or recorded data. So instead of, let's say, go back to the coin flipping example. If you flip a coin, let's say 4 times, and heads only comes up once, then the empirical probability of heads is 1 out of 4. So the empirical is based off observed data, so it's different from theoretical. A couple other things: fair coin or fair die, for example. The event that each side, each part has an equal chance of happening, as opposed to weighted die or weighted coins. And again, this goes back to the idea of theoretical probability with events that are equally likely to occur. The law of large numbers says that the more experiment is conducted, the more likely the empirical probability gets closer to theoretical probability. So again, in the example I mentioned about flipping a coin, if you flip a coin 10 times, more than likely 5 of those flips won't be heads, 5 won't be tails. It'll be more likely in balance. But if I were to flip it 10,000 times, then the overall empirical probability of the heads and tails should be close to 50%. And lastly, we get into odds. Odds are the ratio of the relative likelihood an event will happen versus the relative likelihood it won't. Odds in favor of an event are the probability of the event happening, that's what that PE stands for, divided by the probability of the event not happening, that's what the PE prime stands for. Odds not in favor are just reversed, they're reciprocal. So again, probability PE stands for the probability of a particular event. And PE prime with the apostrophe stands for the probability of the event not happening. So let's look at some examples. Theoretical probability, more specifically, is given by the number of outcomes in an event E divided by the total number of possible outcomes. So for example, with the die, rolling a 2, 1 out of 6. The number of ways I can get a 2 is 1. Total number of possible outcomes is 6. Rolling a 2 or a 3. So in my event, and this is the difference between an event and an outcome, my event is rolling a 2 or 3. An outcome is the 2. 3 is also an outcome. So there's 2 outcomes making up my event. That's why I'm saying an outcome is a single particular event, single probability, whereas a event can be multiple ones. And since we have 2 chances of getting that, it's 2 out of 6, or you can say 1 out of 3. In terms of probability, I don't have a big preference if you reduce. It's one of the few times I won't make you reduce any kind of fraction. So in probability, I don't mind you not reducing fractions, because in a lot of cases it makes a little more sense to keep it in its non-reduced form. Rolling an odd number. How many odd numbers are there on die? There are 3, so 3 out of 6. Another basic example, theoretical, again, probability. In 52 card deck, what is the probability of drawing a king? We have 4 suits, each with 1 king, thus we have 4 chances. So 4 out of 52 possibilities, or 1 out of 13. The probability of drawing a red card, since half the deck is red, we say 26 out of 52, or 1/2. Example from the book. Harold, Kumar, Neil, and Vanessa are friends who belong to the college's 10-person international relations club. I think they made some movies out of this. 2 will be selected to attend a conference. What is the probability that 2 of this group of 4 will be selected? So this should sound familiar. This goes back to section 13.3. This is combinations and permutations. Specifically, combination, because order, that doesn't matter. First of all, we need to figure out what our sample space is. Now, sample space is what are all possible outcomes. In other words, we have 2 people from this group of 10 being chosen. So the sample space is how many ways can we choose 2 people from this group of 10? And we get that through a combination, because again, order doesn't matter, we're just picking 2 people. Using our combination formula, that gives us 45. Now what's probably of our event? Well, specifically, we want to know how many ways can we choose 2 people from a group of 4. And in this case, 4 choose 2, which comes out to be 6. So using our theoretical probability model, we have 6 out of 45, or you could say 2 out of 15. Moving on to empirical probability. Like I said, it's the observed number of times E occurs, or event, divided by the total number of observed occurrences. So, like I said, in terms of flipping a coin, if I flip it 100 times, the empirical probability of heads is how many times of those 100 were heads, and divided by 100, the total number of observed occurrences. You notice after rolling a die 5 times, the 3 came up twice. What is the empirical probability of rolling a 3? Well, I rolled the dice 5 times. 2 of those were 3s, so 2 out of 5. In a study of 250 couples married in the last 10 years, 109 have since gotten divorced. What is the probability of one of those couples getting divorced that we're talking about, this particular group? If 109 have gotten divorced, what's the probability of divorce in this group? Well, it's 109 out of 250, or 43.6%. These are all examples of empirical probability. So again, empirical is just What is the observed information telling? Now find the odds. Like I said, it's the relative likelihood of an event happening versus it not happening. So what are the odds for rolling a 4 or a 6 on a die? So we know from before that the probability of rolling a 4 or a 6 is 2 out of 6. Now I said before on the PowerPoint that we say the probability of the event happening versus not happening gives us our odds. Or you have another option. The odds in favor of event E with probability P of E are A to B if we have this relationship. So 2 over 6 equals 2 over 2 plus 4, so the odds are 2 to 4. And that's the way odds are expressed with the colon. So whether it's odds for or against, the first number is the number of times, or the number that's in our favor. Think of it kind of like a fraction. Now let's look at using the original definition. The original definition said that the probability of odds being in favor with the probability of the event happening divided by the probability of the event not happening. Okay, so let's do that. What's the probability of this event happening? It's 2 out of 6. What's the probability of the event not happening? Let me illustrate this a little better. So the probability of our event, don't want that, is 2 out of 6. The probability of the event not happening then is 4 out of 6. Because again, if 2 out of 6 chances are for it happening, obviously the rest means it doesn't happen. Now the definition said that if I divide one by the other, I get the probability, I get the odds for. So if I divide 2 over 6, by 4 over 6, when you do your rules of division, you'll end up getting 2/4. And we interpret that as 2 to 4, or written out 2 to 4 are our odds for this event. The way I showed you here is a little shortcut you can also use. The general rule is whatever this numerator is, the A, 2, what do I have to add to that to get my denominator? So in other words, what would I add to 2 to get the 6? 4. So the odds are 2 to 4. Let's look at some other examples. Probability of an event is 5 out of 13. What are the odds for? What are the odds against? The odds for, again, think my numerator is 5. What do I add to 5 to get 13? It's 8. So 5 to 8 are the odds for. Against, obviously just reversed. It's the easy way of doing it. And vice versa. If I reverse it, I get 8 out of 13, which is the complement. So again, the probability of event is 6 out of 11. What are the odds against this particular event? Well, since if I add 5 to 6 to get 11, that means the odds for are 6 to 5. So then the odds against obviously are just reversed, 5 to 6. So this concludes section 14.1. As always, if you have any questions, feel free to contact me, and have a good day.